Yeah, hi everyone, welcome to PrepFusion. So now we are continuing our lecture on vector differential calculus. In the last video we studied about gradient. Along with that we studied the basics of divergence and curl. At least we saw the formula. Formula we have seen. Now we need to study the physical significance of divergence. First we will see about the divergence, then we will talk about the curl. Okay. So let's talk about divergence now. So the orientation of a vector field f is given. Okay, there is a vector field f. The orientation of this vector field f is given. Let's just say the vector field f was, we have plotted the vector field f, no? Right? It was somewhat like this. We started plotting the vector field. So it could be in any way. So we have plotted the vector field f, which is looking somewhat like this, around a point A. Because I told you the meaning of divergence, curl or gradient is always defined with respect to a particular point P or a particular point A. The point A could be 1, 0, 1. So this is a particular point A which is having some coordinates. Around this point A, can you talk about the divergence? What you can comment about the divergence, that we are going to see. So this is our vector field f. This is our vector field f. You need to comment on del dot f at point A. So now let's just say you are standing at point A. You are standing at point A. So what you will feel like? Sir, from me, vector field lines are going out. If I am standing here, then I will feel like that, sir, from me, vector field lines are going out. So I am acting like a source of vector fields. I am acting as a source of vector field. That means, sir, from me, vector field lines are going out. So I am as a source, right? So if vector field lines are going out of you, or if vector field lines are diverging out of you, then your divergence would be positive. Vector field lines are going out. So it is, this point A is acting as a source of vector field lines. Field lines are going out of me. So here divergence would be positive. What about the divergence? Again the vector field is f only. What about the divergence at point A in this scenario? What do you think? Sir, if I am standing at point A, I will feel like that vector field lines are coming into me. It is coming into me. Vector field lines are coming into me. So this point A is working as a sink. What is the meaning of sink? That field lines are converging into you. Here field lines are diverging. From you, field lines are diverging. So divergence is positive. If field lines are converging into you, divergence would be negative. The field lines are coming inside you. If it is going out, then it is diverging, it would be positive. If it is coming inside, it would be negative. What do you think? What will be, again it is the field line f. What do you think? What will be the value of del dot f at point A? Sir, if I am standing at point A, sir, 3 field lines are coming from me and 3 field lines are going out of me. And the strength of field lines are same. Sir, whatever that came into me, the same came out of me as well. The number of field lines that came, the same number of field lines are going out as well. So I am neither acting as a source nor I am acting as a sink. So here your del dot f will be 0. 3 field lines came, 3 field lines got out. Strength is same. What about at this particular point A, where field lines are f only? So what do you think? What will be the answer? What do you think? What will be the answer of del dot f? Will it be positive or negative or 0? Sir, 3 field lines came and 3 field lines got out. But here the strength was less, no? Here the strength is more. Sir, less strength field lines came and more strength are going out. That means you are providing the field lines, no? It is like this scenario only, no? That you are giving the field lines. From you, field lines are going out. So here when you are standing, lesser strength field lines came, more strength field lines are going out. That means this will be positive only. Here again the same field lines. This is the point A. What do you think? What will be the value of del dot f at point A? Sir, more strength is coming in, but lesser strength is going out. More strength coming in, less strength is going out. That means you are not providing the field lines, you are eating up the field lines. Here this is eating up the field lines. So field lines is getting into it. Here more field lines is getting into, lesser field lines are going out. What does that mean? It is eating some field lines. That means it will be negative. Let's talk about this scenario. Take any point. Let's just say this point is A, this point is B, this point is C, this point is D, this point is E, this point is F. Let's not take F. This point is G, this point is H, this point is I. And field lines are F only. Okay, vector field lines are F. Now if I am asking you, what is the value of del dot F at all the points? At all the points, what is the value of del dot F? So you can see that, sir, whatever the strength is coming in, the same strength is going out. Whatever the strength is coming in, whatever the strength is coming in, the same strength is going out. Whatever the strength is coming in, the same strength is going out. Everywhere the strength that is coming in, the same strength is going out. That means del dot F would be 0. Is that understandable to you or not? So it shows the nature of divergence of a vector field line, that if the vector field line is diverging or converging. Are you able to understand this point or not? So del dot F at point A, when you are standing at this point A, you are actually acting as a source of field lines. That means you are providing the field lines. That means from you, field lines are diverging. From you, the field lines are diverging. That means del dot F at point A will be positive. Here, if you are standing, that means it will feel like that the field lines are coming into you. Field lines are coming into you. What does that mean? That means it will feel like that you are acting as a sink of field lines. Negative. Here, the number of field lines, the strength of field line, whatever that is coming in, the same is going out. Del dot F is 0. Here, the lesser strength is coming in, more strength is going out. That means you are providing the field lines. Del dot F would be positive. Here, more field lines are coming, lesser is going out. The strength of coming in is more, going out is lesser. That means you are eating up some field lines. What does that mean? You are acting as a sink only. Del dot F would be negative. Here, at every point, whatever the number of field lines, whatever the strength of field line is coming in, the same is going out. Del dot F would be 0. Is that understandable to you? So this is the meaning of divergence. Is that clear? Now the question, you need to calculate del dot R. R is given x I cap plus y j cap plus z k cap. Del dot R you need to calculate. I hope you remember what was del dot F. Let's just say my vector field F is F1 I cap plus F2 j cap plus F3 k cap. So when I calculated del dot F, what was the answer I was getting? So that was, pick whatever that is related with I1, differentiate it with respect to x, differentiate the next one with respect to y, and differentiate the next one with respect to z. And del dot F, since you are doing the dot product, this will be a scalar quantity. I hope you remember it. So what I will do here, del dot R I am supposed to calculate. Sir, first differentiation with respect to x, the quantity of I cap only, plus differentiation with respect to y, the quantity of j cap only, differentiation with respect to z, the quantity of k cap only. What is the answer you are getting? 1 plus 1 plus 1, answer is 3. So you need to remember this, that sir, del dot R vector is nothing but 3. Always remember it in your mind. Again and again, you are not supposed to pick the pen and calculate it in the examination. All you need to remember it, that del dot R is nothing but 3 only. Okay, the answer of del dot R is coming out to be 3. Del dot R vector is coming out to be 3. Do you remember the gradient of R? Do you remember the gradient of R? Gradient of R. Do you remember it? You can write down it as del R. What is R here? R is under root x square plus y square plus z square. What was the gradient of R? So differentiate R 1 and then calculate, then simply add R cap direction. So what was the answer? That was R cap only. I hope you remember it. In the last lecture only we have seen what is the gradient of FR. So first you differentiate your FR with respect to R, then put the direction R cap. So similarly, first I will differentiate R with respect to R, answer I will get 1, and then I will put up R cap direction. So answer will be R cap only. Here the answer would have been F dash R cap. So two things we have seen, that sir, divergence of R will be 3. Gradient of R is R cap. We will see the curl of R as well. Okay. So this is the meaning of divergence that we have seen. Divergence, calculating divergence, that if it is acting as a source, field lines are going out, field lines are diverging, positive, field lines are converging, negative, right? Then we saw del dot R is 3. I hope you remember this formula. How this formula came, that also we have seen. Pick the quantity of I cap, differentiate it with respect to x, plus pick the quantity of j cap, differentiate it with respect to y, differentiate it with respect to z, pick the quantity of k cap. That's it. Okay, answer is 3. What is the meaning of solenoidal or divergence-less vector field? Let's just say there is a vector field F and I am saying it is divergence-less, or I am saying it is solenoidal. What does that mean? That means del dot F would be 0. If I am saying that, sir, this vector field F is divergence-less, this is solenoidal or divergence-less. So what does that mean? That means, sir, del dot F here is nothing but 0. So you need to calculate del dot F. So what will be del dot F? Sir, pick the quantity of I cap and partially differentiate it with respect to x. What you will be getting? 2. Plus pick the quantity of j cap and partially differentiate it with respect to y. What you will be getting? A. Pick the quantity of k cap and partially differentiate it with respect to z. What you will be getting? 4. And equate that to 0. What is the answer of A you are getting? Like basically from here you can see that A plus 6 is coming out to be 0. Why it is coming out to be 0? Because it is given that, sir, vector field is solenoidal. So value of A is coming out to be -6. What is the meaning of vector field being solenoidal? That means del dot f would be 0. That's it. So what is the meaning of solenoidal vector field? Del dot f should be 0 at all the points, at every point. At all the points, del dot f would be 0. Okay. So from here we got the answer a equals to -6. Let's see the next. We will talk about curl now. So curl talks about circulation. Okay. It talks about circulation, or you can say rotation. Rotation. So let's see this example first. So what is the vector field? Vector field is f only. I am talking about del cross f. I am talking about del cross f at a particular point A. Okay. This is what we are talking about. So first of all, you let me know what was del dot f. It was a scalar quantity. Del dot f was a scalar quantity. Del dot f was a scalar quantity. It could be either positive or 0 or negative. What is del cross f? So del cross f will be a vector quantity. And vector quantity cannot be positive negative, no? If I write down -3 I cap, will you say this is a negative quantity? No. You will say that, sir, magnitude is 3 only and the direction is -I cap. This is what you will say, no? So a vector quantity cannot be positive negative. A scalar quantity could be positive negative. Sir, my marks are -3. Sir, my marks are +4. So it is a scalar quantity, it could be positive negative. But when we talk about vectors, so vector will have some magnitude and the direction. So here what we will talk about? We will talk about the direction only. What we will talk about? Direction. So first of all, we will talk whether it is 0 or non-zero. And if it is non-zero, then we will talk about the direction. So how you need to check? At point A, if I put a ball, okay, if I put a tennis ball here, and I am providing the force in this manner, okay, this is the force, let's say this is force only. You are providing the force in this manner. There is a ball, there is a tennis ball here at this point A, and you are providing the force in this manner. Will the ball rotate? Yes, sir, surely it will rotate. And in which direction it will rotate? Sir, it will rotate in this direction. Use the right hand rule. Rotate your hand in this direction. What is the direction you are getting? Sir, I am getting the direction of a dot. That means coming towards me. So del cross f will be non-zero and direction would be coming towards me. Just put a ball here. Will this rotate? Absolutely it will rotate, sir. And in which direction it will rotate? It will rotate in this direction. Use the right hand rule. Direction of del cross a will be coming towards me. Put a ball here. I am talking about this vector field. Put a ball here, del cross f at A. Put some ball here. Will the ball rotate? Equal force I am putting. This is the ball. This is the ball. I am putting equal force here as well, here as well, here as well. Equal force I am putting. Will the ball rotate? No. There will be no rotation. No circulation would be there. Del cross f would be 0 only. Here it would be non-zero and direction would be coming towards me. What about this guy? Del cross f at point A. This time you are putting the force in a bit different manner, no? You are pulling it somewhat like this. You are pulling it somewhat like this. You are pulling somewhat like this. Will the ball rotate? This time the force is not like this, that it is equal force here, equal force here. In a bit different manner you are putting up the force. And let me make it a bit more better way. Okay, in a bit more better way I will make the field lines. Here it is not looking good. So what you can see here at point A, if there is a ball at point A, then aren't you pushing them in one direction only? Isn't it in clockwise direction only? Like, aren't you pulling the ball in clockwise direction only? It is not like this. If you see this arrow, that how you are pulling the ball, there is a curvature, no? You are pushing the ball in this manner. That you are pushing this ball in this manner, in this manner, in this manner. Always clockwise only. So where the ball will rotate? The ball will rotate clockwise. The ball will start rotating clockwise only. Say yes or no. And if it is rotating clockwise, use the right hand rule. Direction is going inside. So it would be non-zero here. I hope you are able to understand. It would be non-zero and direction is going inside. Although the diagram is not that clear, but when you see the diagram in the examination, all it will be much clear. You would get to know that yes, ball will be rotated somewhat like this. Direction is going inside. Put the ball here. Will that be rotated? Absolutely, sir. You are rotating in this manner, no? You are putting up the force in this manner. Putting up the force in this manner, So surely the ball will be rotated. Here you put the ball and you are putting up the force here in this manner. You see the vector field F. So ball will be rotated, absolutely. In which direction it will be rotated? Sir, it is clearly visible, it will be rotated in this direction. So what will be the answer? Sir, del cross F would be surely non-zero, and ball will be rotated in this direction, that means direction is going inside, so cross, this will be the direction. Understandable? Sir, what about this? Put a ball here. The equal force I am putting here, the same amount of force I am putting here, and the same amount of force I am putting here. Both of the side I am putting the same force. Will the ball rotate? No. Same force here and same force here. Will the ball rotate? Like I am pulling the ball from the same force in both of the side. From the same force in the both of the side. Will the ball rotate? Absolutely not. What does that mean? That means del cross F at point A will be 0 only. What about this scenario? Del cross F at point A. पता नहीं यार हाथ में क्या हो रहा है. Not sure why handwriting is not coming good. Del cross F at point A is coming out to be 0. Del cross F at point A. What do you think? Will it be 0 or non-zero? Sir, I am putting the force this side as well. I am putting the force this side as well. I am putting the force this side as well. But sir, on this side I am putting more force. More force I am putting. On this side I am putting more force. So if I am putting more force, then what will happen? The ball will actually rotate. Right? Here if you put more force, in this direction we are putting more force. So actually the ball will start rotating in this manner. Say yes or no? More force here, lesser force here. So because of this more force, the ball will rotate. In this manner it will rotate. What will be the direction? It will be non-zero. What will be the direction? Direction will be going inside. Right? Direction will be going inside. Is that understandable to you or not? Just put the ball and see whether the ball will rotate or not. Here ball will rotate, equal force is there. No. Here all the force we are putting in clockwise direction. Yes, ball will rotate in clockwise direction. Here everything we are putting in anti-clockwise direction, ball will rotate. Here everything we are putting in clockwise direction, ball will rotate. Here equal force, no ball rotation. Here more force this side, lesser force this side, ball will rotate in this direction. Based on the direction, use the right hand rule and tell the direction of curl. If the ball is rotating in the clockwise direction, inside. If it is moving in the anti-clockwise direction, coming outside. That's it. Okay. So did you understand the physical significance of divergence and curl? Now someone would be having a doubt that sir, here you talked about only the sign, no? Positive, negative, 0, 0, positive, negative. Sir, here I got the answer 3. I know that it is positive. I know that sir, answer is 3. It is positive. That means sir, at any point if I see the vector field, no, they will feel like it is going out. It is fine. Sir, answer is positive. Sir, since the answer is positive, if I draw this vector field, can you draw this vector field around point 0? You draw this vector field. How the vector field will look like? Sir, it is position vector only. So this is how the vector field will look like. So you can see that sir, around this point 0, you can see vector field lines are going out. So it is acting as a source. That means del dot A, del dot R should come as positive only, which is coming positive. Yes, del dot R is coming positive. Sir, what does this 3 represent? That you did not tell, right? What does this 3 represent? Positive, fine. If it was negative, that means field lines would be converging. That is also fine. But what does this 3 represent? What is the meaning of this 3? So what does the magnitude represent? That you did not tell. No, you only talked about the sign. So what magnitude represents, that I will tell you once we study integral calculus. Once we are done with the integral calculus, no, at that time I will tell you what does the magnitude represent. That will be the next lecture only. In next lecture only I will be telling you that what does the magnitude represent for a divergence. Here only sign we have talked, that positive sign, negative sign. In the examination only sign has been asked. Okay. Although they did not even ask the sign, they only asked a non-zero or 0. This has been asked, that it will be 0 or non-zero. It will be, if it is negative, it will be non-zero. If it is positive, it will be non-zero. Here it is 0 only. So only they have asked about 0 or non-zero. We have talked about the sign as well. Along with that, we will talk about the magnitude as well, that what magnitude represent in the next video when we study about integral calculus. Similarly, here as well, sir, you talked about the curl, right? It would be 0, it would be negative, sorry, it would be 0, it would be non-zero. Direction you have talked, but what does the magnitude represent? Let's just say, sir, my answer is 3 I cap. So I know that, sir, direction of curl is in the I cap direction, but what does this 3 represent? That we need to understand, no? So what does the magnitude represent? That we will talk in the next lecture. Okay. As of now, we are only talking about the direction. So how we get to know the direction? Put the ball, whether it rotates or not, in whichever direction it is rotating, use the right hand rule and you get to know the direction of curl as well. Understandable? Well and good? Okay. Let's calculate the curl of R. What we already know, sir, gradient of R came out to be R cap. Sir, divergence of R came out to be 3. Now we need to calculate curl of R. What that would come out to be? That would most probably, I know the answer, but you calculate on your own. So del cross R we need to calculate. यार हैंडराइटिंग नहीं सही आ रही है भाई आज. Del cross R we need to calculate. I cap, J cap, K cap, del by del X, del by del Y, del by del Z. X, Y, Z. What answer you are getting? Sir, I cap. Partial differentiation of with respect to partial differentiation of Z with respect to Y will be 0. Partial differentiation of Y with respect to Z will also be 0. Minus J cap. Partial differentiation of Z with respect to X 0. Partial differentiation of X with respect to Z 0. Plus K cap. Partial differentiation of Y with respect to X 0. Partial differentiation of X with respect to Y 0. What is the answer you are getting? 0. So curl of R is 0 only, and it is pretty obvious, right? Why it is pretty obvious? All three answers we have. Why curl of R is 0? Because how the vector field would represent, how the vector field will look like. This is how the vector field will look like, no? Because this is your position vector. So how the position vector look like? How the position vector looks like? So position vector looks somewhat like this. This is how the position vectors look like. This is how the position vectors look like. Right? So if you put the ball here, actually equal amount of force would be there, no? If you put the ball here, will the ball rotate? If you put the ball here, will the ball rotate? No, it will not rotate, right? Because equal amount of force is there, no? The same example that we took here, this example, the ball will not rotate. So del cross R will be 0 only. What about del dot R? Is it positive? Yes, sir, it would be positive. Why is that so? Because field lines are going out, so it is positive. Yes, sir. What about the gradient? Gradient will say that if you move in this direction, no, then you will get the maximum change. Is that true? Yes, that is also true. So if you move in the direction of R cap, then you will get the maximum change. That is also true. Is that understandable to you? So this is your x-axis, y-axis. Oh, sorry. This is your x-axis, this is your y-axis, and this is your z-axis. X cross y, z. Understandable? Okay, so all three we are supposed to remember. Although I will write down in the next page as well somewhere, but we are supposed to remember this. Okay, del R, R cap directly, del dot R 3, del cross R 0. Directly it should be remembered by you. Let's go to the next one. What is the meaning of irrotational vector field? What do you think if a vector field F is irrotational? What does that mean? Del cross F would be 0. Irrotational means there is no rotation, there is no circulation. That means its curl will be 0. So vector field R is irrotational, right? It is irrotational. Vector field R is irrotational. Is it divergence? Is it divergenceless? No. Is it solenoidal? No. But it is irrotational. Irrotational. Rotational. Rotational. It is irrotational. Okay. So this question is given during a medical research. This kind of theory has been written. Eventually, what they are saying that in a specified region, the fluid flow, this flow is irrotational. Okay, this flow is irrotational. Then find out the value of A. So eventually, what they are saying that del cross vector V. Okay, del cross vector V is 0. This is what they are saying. So what you need to do, you calculate the curl and you equate that to 0. I cap, J cap, K cap. 4xy minus z cube 2x square plus az y minus 3x z square. That should be equated to 0. So what you get? I cap. Partial differentiation of this particular function with respect to y. What is the answer you get? 1. Partial differentiation of this particular function with respect to z. What is the answer you will get? E. From here only I can get to know that answer will be a equals to minus 1. But let's proceed. If you partially differentiate this function with respect to x, then what answer you will be getting? Minus 3z square. If you partially differentiate this function with respect to y, what you will be getting? Minus 3z square only. sorry, with respect to z, because this we are doing, no, partial differentiation with respect to z. So you will be getting minus 3z square only. So minus 3z square will be this scenario, minus plus k cap. If you partially differentiate this function with respect to x, what you will be getting? 4x. And if you partially differentiate this particular function with respect to y, what you will be getting? 4x only, minus 4x. So what you can see from here, this we need to equate it to 0. So from here what we are getting, this is 0 only, this is 0 only. So 1 plus a I cap is coming out to be 0. So for this to be equals to 0, what does that mean? 1 plus a has to be 0. 1 plus a has to be 0. What does that mean? A has to be equals to minus 1. This is the answer. A has to be equals to minus 1. So what is the answer? A has to be equals to minus 1. That's it. So irrotational vector field is given. I don't know how many times such question have been asked in GATE examination. Irrotational vector field they will give. Simply you need to calculate the curl and equate it to 0. You will get the unknown variable. At least 4 or 5 times this kind of question has been asked, and very straightforward question. Just simply put the curl equals to 0, get the answer. And I hope you know how to calculate the curl. I cap, partial differentiation, partial differentiation. Similarly, j cap, then partial differentiation, then k cap, partial differentiation. Equate that to 0. Job done. Next question. Vector field is irrotational. This is the GATE QIQ only. You need to find out the value of k1, k2, k3. Okay. Vector field is irrotational. What does that mean? That means, sir, del cross f is 0. What does that mean, sir? That, sir, I will again make I cap, j cap, k cap, j cap, k cap, del by del x, del by del y, del by del z. 3y minus k1z, 3y minus k1z, 3y minus k1z, k2x minus 2z, k2x minus 2z, minus k3y plus z. Plus z, k2x minus 2z, 3y minus k1z. Okay, so let's solve it. First I cap would come, then partial differentiation of this function with respect to y, what answer you will be getting? Minus k3. Then partial differentiation of this function with respect to z, what is the answer you will be getting? Minus 2. So this will become plus 2. Minus j cap. Partial differentiation of this function with respect to y, what is the answer you will be getting? 0. And partial differentiation of this function with respect to z, what is the answer you will be getting? Minus k1 plus k cap, what you will be getting? K2. Partial differentiation of this function with respect to y, what you will be getting? 3. K2 minus 3 equals to 0. So what you can see from here, that, sir, all of them has to be 0. No, this has to be 0, this also has to be 0, and this also has to be 0. So 0 into I cap minus 0 into j cap minus 0 into k cap will be 0 only. So what you can see, k3 has to be equals to 2, k1 has to be equals to 0 only, and k2 has to be equals to 3. These are the answers: 0, 3 and 2. 0, 3 and 2. 0, 3 and 2 is the answer. Understandable? Very simple. Del cross f equated to 0. Get the equation. Sir, everything, this has to be 0, this has to be 0, this has to be 0. Job done. Understandable? So what is the meaning of solenoidal or divergence less vector field? So that is simply del dot f equals to 0. And what is the meaning of irrotational? Other name is conservative. We will talk about it when we study integral calculus. So if the vector field is conservative, then del cross f is 0. So other name is conservative. Okay. So we will talk about conservative field again when we study integral calculus. So two names are there: solenoidal or divergence less, del dot f is 0. Irrotational or conservative, del cross f is 0. Is that clear? Now next question is there, that vector field f is given. What you need to calculate? First you calculate the gradient. Then after gradient, what you will get? What will be this quantity? So this quantity will be a vector quantity. No, when I calculate the gradient, this will be a vector quantity. So this will be a vector quantity. Let's just call it f vector. So after that, what you do? You calculate the divergence. This is what they are asking. So first you calculate the gradient, then you call it f vector, and then you calculate the divergence. This is what they are asking. That means first they are asking you to calculate the gradient of f. Gradient of f. So how do we calculate the gradient of f? If you remember it, hopefully or surely you should be remembering it. what do we do? First, partial differentiation with respect to x. Whole function will be partially differentiated with respect to x. So answer will be 2x I cap plus partial differentiation of whole function with respect to y. What will be the answer? Z cube, because this will be constant 0. Z cube will come as will be coming outside. The partial differentiation of y will be 1. So z cube j cap plus z cube j cap plus partial differentiation of this function with respect to z. What will be the answer? Y will be constant, so 3y z square, 3y z square k cap. So this is your vector f. Next, what you are supposed to calculate? You are supposed to calculate del dot f, which is coming out to be del dot del f. What is the answer you are getting? What is the meaning of del dot f? Is this function is given. So partial differentiation of this function with respect to x 2 plus partial differentiation of this function with respect to y 0. Partial differentiation of this function with respect to z, what that would be? Partial differentiation of this function with respect to z. What answer you will get? 6yz. So what is the answer you are getting? 2 plus 6yz. So this is the answer of your question. This is the answer of your question. 2 plus 6yz. Is that understandable to you? Okay. Now let's see one more thing here. Let's calculate something known as del square by del x square f plus del square by del y square f plus del square by del z square f. This is what I am trying to calculate. F is given, no? What is this, sir? I will let you know. I will let you know what is this. But let's calculate this particular thing. Del square by del x square. What is f? F is nothing but x square plus yz cube. X square plus yz cube. What does that mean? That means you need to partially differentiate this function with respect to x twice. So when you partially differentiate one time, what is the answer you get? 2x. When you partially differentiate again, what answer you will get? 2 only. So here I am getting the answer to be 2 plus. You need to partially differentiate this particular function, which is x square plus yz cube with respect to y twice. With respect to y, you need to partially differentiate 2 times. So when you differentiate for the first time, what you will be getting? With respect to, sir, y I am differentiating, so I will get z cube, because y will be a constant value. So z cube only we got here. And then again you need to partially differentiate with respect to y only. What answer you will get? 0. Because z cube will be a constant value, right? Plus the same function partially differentiated with respect to z 3 times. Same function partially differentiated with respect to z 3 times. Sorry, 2 times, not 3 times, 2 times. So which is x cube plus yz cube. So partial differentiate 2 times. First time if you differentiate, what you will be getting? 3yz square, right? 3yz square. Again you differentiate, what you are getting? 6yz. What you are getting? 6yz. So what is the answer you have? 2 plus 6yz. Is it the same answer? Is it the same answer that you are getting? 2 plus 6yz. Yes, sir, it is the same answer. What this is known as? Here, can I write it down in this manner? Del x square plus del square by del y square plus del by del z square, and then f outside. What is the answer we are getting? 2 plus 6yz. So this particular operator, this is a new operator, no? This particular operator is known as del square f. Okay, and the name of this operator is Laplacian operator. What is the name? The name of this operator is Laplacian operator. So we have studied about del operator, no? What was del operator? So del operator was del by del x I cap plus del by del y j cap plus del by del z k cap. So this was my del operator. Now I have studied another operator, which is a Laplacian operator, which is del square by del x square plus del square by del y square plus del square by del z square. Okay, partial differentiation with respect to x, then again partial differentiation with respect to x, plus partial differentiation with respect to y, again 2 times you need to partially differentiate. So this is known as del square f. So here when they were asking about del dot del f, that means divergence of gradient of f, divergence of gradient of f. divergence of gradient of f, then it would be equals to the Laplacian of f. Laplacian of f. So this particular term, divergence of gradient, is equal to the Laplacian. What they were saying, divergence of gradient of f. Gradient of f you calculate and then you take its divergence, that would be equals to del square f. Is that understandable to you or not? So kind of, if someone looks at it in this manner, in what manner? If someone is looking at it in this manner, that sir, you have said del dot del f is coming out to be del square f. So if someone is trying to compare, can he compare in this manner, that sir, it was del dot del f, right, equals to del square f. Del dot del f equals to del square f. So can someone say that sir, del dot del is coming out to be equals to del square? Del dot del is coming out to be equals to del square. From here to here. Say yes or no. Now let's try calculating del dot del. What is del dot del? Del by del x I cap plus del by del y. भाई आज हैंडराइटिंग ही क्या हो रहा है यार. Del by del y g cap plus del by del y k cap plus del by del z k cap. Dot product with del by del x I cap plus del by del y j cap plus del by del y plus del by del z k cap. Can you do the dot product? Yes sir. Someone would say that sir, if I do the dot product, no, what is the answer I am getting? Del by del x whole square plus del by del y whole square plus del by del z whole square. So this is the answer I am getting. It is not equals to this particular scenario. D by dx, is it a number or an operator? D by dx is a number or an operator. When in mathematics, when I do d by dx of y, what do I write down? So d by dx, do I write down in this manner? D by dx of whole square y. Do I write down in this manner? No. What do I write down, sir? d2x by dx to y. That means you need to apply d by dx operator twice. This is what you say, no? Because it is an operator, it is not a number. D by dx is not a number, it is an operator. That you are calculating d by dx of y. You are calculating d by dx of z. D by dx of some function. It is an operator, no? When you write down in mathematics d by dx, then d by dx of y, do you do the square? No. It is an operator, that means you are applying the same operator twice. So when I am saying del by del x, both are being multiplied. So what I am doing? I am doing the same operation twice, no? Are you able to understand this point? A very, very interesting thing. It is not a number, it is an operator. So what will be the result? What will be the result here? The result will come out to be del square by del x square plus then j cap del square by del y square plus del square by del z square. And what does they mean? They simply mean one thing, that you need to partially differentiate the same function twice with respect to x plus partially differentiate the same function with respect to y 2 times and with respect to z as well 2 times. And this is known as Laplacian operator. Okay. The actual meaning of Laplacian operator, even if you have studied somewhere before as well, but today you would have understood. Okay. Now I will ask you a very interesting question, and I am pretty sure you wouldn't be having an answer. Sir, just now you said that, sir, d by dx is an operator, right? D by dx is an operator. Let's just say I do d by dx of y, and the answer I am getting is fx. This is the answer I am getting. Now in mathematics, I am pretty sure you know that I can write down dy equals to fx dot dx, right? And from here I can write down y equals to integration fx dot dx with the limit going from minus infinity to x. Say yes or no. Is there anything wrong in whatever the analysis that I have done? Is there anything wrong here? Not related to your course or anything, just some maths I am asking. Okay, let's see the beauty of maths. So d by dx of y fx, I can do this particular thing, that I took dx this side. How I can take dx this side? Just now I said that, sir, d by dx is operator. That means d by dx combined will make any sense, no? Alone dx should not make any sense. Like just now I said that, sir, it is not a number. But what I am doing, 3 by 5 into 4 is equals to 12 by 5. So what I did, I took 5 this side. This is what I have done, no? D is, let's just say 3, or let's just say let's say one thing, that 3 by 5 equals to x is given. So dy is my 3, dx is my 5, and x is given here, which is fx. So this is what I have done, that sir, I have taken 5 this side. So what I am getting, 3 equals to 5x. So I have treated dx as a number. Dx is a number. But just now you said that, sir, d by dx is an operator. It is not a number. But you are treating dx as a number, no? Because if it is a number, then only you can put it this side. You cannot throw it this side if it is an operator. It is a number. So you are treating dx as a number, but d by dx as an operator. So yes, this is the scenario, that d by dx is actually an operator, but you can treat dx as a number. Dx is a number only. So whenever we put dx this side, whenever we study differential equation, we treat dx as a number only. From our childhood, I should not say childhood, from class 11, 12th, we are doing this thing. But why it did not click to your mind that, sir, d by dx is an operator? No. How you are breaking the operator? You have broken the operator here, no? This was dy by dx, and you have simply broken the both of the operator, dy separate, dx separate. But we started from here. So you are treating dx as a number actually. So yes, dx is a number which is representing the small change in x. So d by dx and dx both are complete different things. That's why differential equation is treated as a separate subject. It is not included in calculus. Calculus is different, differential equation is different. Because in differential equation we treat dx as a number. Are you able to understand this point? And where these kind of lines are written? In the book who does not get any respect, NCRT, class 12 NCRT. So Leibniz told all these things. Okay, he told that dx could be treated as a number while d by dx is an operator. So whenever you get time, no matter whichever the subject you are comfortable with, or whichever the subject you are interested in, always read NCRT. The guy who has written NCRT, he is brilliant. Like, he is having so much of knowledge, but he needs to write down the book in a manner that it should be comfortable for every average student of class 11, 12th. Like when you talk about R.D. Sharma, or when you talk about H.C. Verma or Singage, these kind of books are already written in much depth, right? Those books are not for any average student. If someone wants to solve these kind of books, that means he needs to be very talented. But NCRT, everyone thinks that's okay, it is a very average book. But the guy who has written it, he is very talented. He is very knowledgeable. So even after having so much of knowledge, he needs to write down a book in a manner that everyone would be able to study it. That is appreciable, no? H.C. Verma sir has wrote his book. So whatever the knowledge he is having, he has given all the knowledge. Singage, whatever the knowledge he was having, gave all the knowledge. R.D. Sharma, whatever the knowledge he was having, gave all the knowledge. But NCRT guy, a lot of knowledge he is having, but he needs to frame the language in a manner that even a class 11, 12 guy should be able to understand this kind of concepts. And an average student is able to understand. So this should be highly appreciated. Okay, highly appreciated. It is not that easy to do this thing, right? So yeah, just telling, like, this is not relevant for your GATE examination, but it's something that in interview these kind of things could be asked. That let's talk about Laplacian operator. So del dot del f, then they would see del by del x dot product with del by del x. It should be del by del x whole square. How you are writing down del square by del x square? So operator number, del by del x is an operator. It is not a number. Is that understandable to you? Okay. So this is your Laplacian operator. So what is the summary? The bottom line is, sir, this was my del operator. What will be the Laplacian operator? So Laplacian operator would look somewhat like this. So it would look del square by del x square plus del square by del y square plus del square by del z square. In the examination, if they are asking del square f, calculate del square f, what I will do? I will take the function partially differentiated with respect to x 2 times. I will take the function partially differentiated with respect to y 2 times. I will take the function partially differentiated with respect to z 2 times. Job done. What is the meaning of harmonic vector field? Harmonic vector field means Laplacian is 0. sorry, harmonic scalar field, not vector field. Harmonic, what is the meaning of harmonic scalar field? That its Laplacian is 0. That's it. So what we have studied? Solenoidal, irrotational and harmonic. What was solenoidal? Solenoidal was del dot f equals to 0. Irrotational was del cross f equals to 0. And what is the meaning of harmonic scalar field? Del square f equals to 0. So this is the question. The scalar field is harmonic. Find out the value of a. What does that mean? Take the whole function. What you need to do? So del square phi will be equals to 0. That means take the whole function, partially differentiate it with respect to x 2 times. So when I differentiate it one time, what I am getting? 2ax plus 2ax minus 4y. Then again differentiate it, what you are getting? 2a. So 2a plus, next partially differentiate it with respect to y. So one time you differentiate 6y minus 4x plus 2z, right? 6y, this will be 0, this will be 0. Here what you will getting? Minus 4x plus 2z. Then again you partially differentiate it. What is the answer? You will get 6 plus, right? If you partially differentiate, this will be gone, 6 will be left. Now again you partially differentiate with respect to z. When you partially differentiate with respect to z, what you are getting? 10z plus 2y. Then again you partially differentiate, answer is 10 plus 10 equals to 0. So what answer we are getting? A equals to minus 8. That's it. Okay, so this is how we need to solve the question. Partially differentiate with respect to x 2 times plus partial differentiation with respect to y 2 times and partial differentiation with respect to z 2 times. Add all of them, get the answer. Okay, so this is the meaning of Laplacian. Not very important, but who knows, one question might be asked in 1 mark that sir, if it is harmonic, if your scalar field is harmonic, then find out the value of A. Very simple concept. What is the meaning of Laplacian operator? That also you have understood. Divergence of gradient. This is what you need to understand. That sir, first I was having a vector field. First I was having a scalar field. I was having a scalar field. So with this scalar field, using the del operator, what I can do? I can only do one thing. That is calculating the gradient. So if I am having a scalar field, I can only do one thing. I can calculate the gradient. Once you have calculated the gradient, what you are getting? So this will be a vector quantity. Now if I am having a vector quantity and I need to apply the del operator, then I can do two things. Either I can do the dot product or I can do the cross product. So if I do the dot product, what I am getting? Del square phi. If I do the cross product, what I will get? This answer will come out to be 0. That we will see in the next slide. Okay. Actually, this particular answer will come out to be 0 only. If you are having a scalar field function, you can do only one thing. Using the del operator, you can do only one thing. You can calculate the gradient. Once you calculate the gradient, what you will get? This will be a vector quantity. Now, since it is a vector quantity, along with that you are having a del operator as well. You can do two things now. One would be dot product, other one would be cross product. So dot product, when I do, it is known as Laplacian. And sir, when I do the cross product, the answer will come out to be 0. How it will come out to be 0? How to remember it? Everything we will see. Okay, have some patience. Everything we will see in the next slide only. Because someone would be having the doubt, no sir, what if I do the cross product? So when you do the cross product, no, it will come out to be 0. So it is curl of gradient. What I will say, what this is? This is your divergence of gradient, right? It is divergence of gradient of f or of phi. And what this is? This is curl of gradient. Okay. So let's see the next question. You need to find out the divergence of curl of f. What you are supposed to find out? First you calculate the curl of f. So when you calculate curl of f, what quantity you are getting? Sir, it will be a vector quantity only. So after that, what you do is that you calculate its divergence. This is what you are supposed to calculate. Okay, let's just call it vector A only. So first you are supposed to calculate curl of f. What you will be getting? Sir, curl of f I am supposed to calculate I cap, j cap, k cap, and sir, that I am equating it to a vector. Okay, so curl of f I am supposed to calculate. Sir, it is not a very difficult task. Very simple it is. Del y del x, del y del y, del y del z. xy, zx, yz. What is the answer I will get? Sir, partial differentiation with respect to y. Partial differentiation with respect to y will be z. And then partial differentiation with respect to z will be x. Plus, not plus, minus. Partial differentiation with respect to x will be 0. Partial differentiation with respect to z will be 0. Plus k cap. Partial differentiation with respect to x will be z. And partial differentiation with respect to y will be x. Wait a second, something wrong we are doing. I cap partial differentiation with respect to y will be z, partial differentiation with respect to z will be x, and here k cap partial differentiation with respect to x will be z only. अरे कहाँ गड़बड़ हो रही है भाई? Partial differentiation with respect to y will be z, xy zx yz. Okay, xy zx yz. Partial differentiation with respect to y. So what you will do? Z you take common. Then here with respect to z, x you take common. For j cap, partial differentiation with respect to x gone. It is gone 0. Plus k cap, partial differentiation with respect to x, z you take common, and then partial differentiation with respect to y. What you take common? X you take common. So this is your del cross f. Yeah, it is correct only. So this is your vector A you are getting. Okay, this is the vector A you are getting. What you are supposed to calculate? You are supposed to calculate del dot A. So can you calculate del dot A from here? Partial differentiation of this function with respect to x. What is the answer you will be getting? -1. Plus partial differentiation of this function with respect to y. What is the answer you will be getting? 0. Partial differentiation of this function with respect to z. What is the answer you will be getting? 1. What is the answer you are getting? 0. So what did you understand? Del dot del cross f is coming out to be 0. What you are getting? Divergence of curl. Divergence of curl is coming out to be 0. Divergence of curl, if I write down in shortcut, dc equals to 0. dc equals to 0. There is a team in IPL. The name of that team is Delhi Capitals. The name of the team is Delhi Capitals. Delhi Capitals. How many IPL trophies they have won? 0. Okay, so always remember DC equals to 0. Or you just remember our Delhi capital. What is the condition of Delhi nowadays? Pollution and everything. We are at level 0 only, no, in Delhi. Don't be offended, but it is what it is. The condition of Delhi is like very bad as of now. So just remember Delhi capitals equals to 0. DC equals to 0. So divergence of curl will always come out to be 0, no matter whichever the function you take. Any random function you take, any random vector field you take, and always you calculate, divergence of curl will always come out to be 0. Okay. There is another way of understanding it. Let's just say this is a plane. Although del is an operator, but let's treat it as a vector only. I am treating as a vector quantity. Although it is a vector operator, but I am treating it as a vector quantity. Let's just say this is your del. Okay. And this is your f. This is your vector f. Del is not a vector quantity, sir. It is an operator. But still, let's treat it as a vector quantity only. So I am treating del as a vector quantity, and this is your vector f. This is your vector f. This is your vector f. Now, can you let me know what will be the direction of del cross f? So direction of del cross f would be, it will be perpendicular to the plane containing both del and f. So what will be the direction? This will be the direction of del cross f. This will be the direction of del cross f. Now let me know what is the angle between del cross f and del. The angle between del cross f and del is 90 degree. So if you calculate the dot product of del and del cross f, you are doing the dot product between them. The angle between del cross f and del is 90 degree. If you do the dot product between two perpendicular vectors, what will be the answer? 0. Another way of remembering it or understanding it, the answer will be 0. Always remember only one thing, sir. Delhi capital DC equals to 0. Divergence of curl will always come out to be 0. Here what we understood, divergence of gradient will not be equals to 0. It is Laplacian. But divergence of curl is coming out to be 0. DC equals to 0. Another thing is CG, curl of gradient. CG. What is your class CGPA? Sir, very low. It is equals to 0 only. What is your CGPA in class? CG equals to CGPA. Curl of gradient. That is equals to CG. And what is your CGPA in class? How much CGPA are you getting? 6 CGPA. which is nearly equals to 0. Don't be offended, don't feel bad, just a way to remember. Only two things are 0. Delhi capitals 0 and CG equals to 0. Only two things are 0, that's it. Divergence of curl is 0, curl of gradient is 0. Now if anything else they are asking, let's just say they are asking divergence of gradient, then you will think, sir, it is not equals to 0. Only 0 you need to remember. These are known as null identities. What they are known as? Null identities. So only two things are 0 actually. Okay. So DC and CG. Delhi capitals 0 trophy, sir. CG is already 0. Divergence of curl, curl of gradient. Two things only you need to remember, nothing else. Okay. Rest, whatever that they are asking, we will calculate. Is that understandable to you or not? Completely understandable. Just check it. F is given. What you need to calculate? Curl of gradient of f. So first you need to calculate the gradient of f. So gradient of f will give me a vector quantity. Let's just say it is vector a, and then I am supposed to calculate the gradient. Sorry, then I am supposed to calculate the curl. This is what I am supposed to find out. So first I need to find out a gradient of f. So partial differentiation of this function with respect to y. Sorry, with respect to x, that will be yz I cap. Partial differentiation of this function with respect to y, that will be xz j cap. Partial differentiation of this function with respect to z, that will be xy k cap. So this is my vector A. I am supposed to calculate del cross A. I am supposed to calculate del cross A. Again, sir, the same thing, I cap, j cap, k cap. I cap, j cap, k cap. Del by del x, del by del y, del by del z. Yz, xz, xy. So you can check it, you can check on your own. If you partially differentiate this function with respect to, okay, let's do it. Although you should be checking on your own, okay, but this kind of calculation, although it is a recorded lecture, I cannot do anything. So yz, xz, xy. So partial differentiation of this function with respect to y, answer will be x, right? Then partial differentiation of this function with respect to z, answer will be again x, minus j cap. Partial differentiation of this function with respect to x, partial differentiation of this function with respect to z, partial differentiation of this function with respect to x, partial differentiation of this function with respect to y. So what is the answer? 0. So del cross A is coming out to be 0 only. Del cross A is coming out to be 0 only, or you can say del cross del f is also coming out to be 0. Another way of checking it. What will be the direction of del f if I treat it as a vector quantity? Sorry, if I treat it as a vector quantity, del is actually an operator, sir, but let's treat it as a vector quantity only. So what will be the direction of del f? If this is the direction of del, let's just say this is the direction of del, this is the direction of del, then what will be the direction of del f? Like, let's just say the direction of vector A is this. What will be the direction of 3A vector? It is same, no? F is just a vector quantity. So treat this as a vector, sorry, f is just a scalar quantity. So treat this as a quantity as well and treat this as a quantity as well. So you are calculating del f. So what will be the direction of del f? That will be same as the direction of del only, no? What will be the direction of A vector? This is the direction of A vector. What will be the direction of 3A vector? So that will be the same only. So similarly, what is the direction of del vector? That is this. So what will be the direction of del f? That will be the same only, no? So direction of del and direction of del f will be same. Now you are doing the cross product with del only. You are doing the cross product with del only. That means they are in the same direction. They are in the same direction. What is the cross product of I cap cross I cap? 0. What is the cross product of cross A cross A? That is also 0. So what will be the value of del cross del? That will also be 0 only, no? Because they are in the same direction. Magnitude of del multiply with the magnitude of del sine theta. What is the angle between them? 0 degree. Sine 0 is 0 only. So del cross del will be 0 only. What does that mean? So del cross del f will be nothing but 0 only. Is that understandable to you or not? Because sir, whatever the direction of del is there, the same direction del f will also have. Because sir, f is just a scalar. It will not change the direction. Or it can, let's just say f is negative. Someone would say, sir, f is negative. So it will change the direction by 180 degree. Doesn't matter. What is sine 180? Sine 180 is also 0 only. Right? So basically, del and del f will be in the same direction. So if you calculate the cross product of del with del only, cross product of del with del, what answer you will get? Same direction. That means cross product will be 0. So this is another way of understanding it. Okay, so two null identities are there. At the end of the day, you need to remember this thing. DC, CG. Delhi Capitals 0, CGPA is already 0. Okay. Curl of gradient CG 0. Divergence of curl DC 0. That's it. So what is the meaning of curl of gradient? Sir, curl of gradient you will always calculate for scalar quantity. Next, divergence of curl. So this is also coming out to be 0. What else we have studied? This we have studied. What was this? Divergence of gradient. Although I don't remember it, DG, divergence of gradient. Sir, this will not come out to be 0 because they are in the same direction and there is a dot product between them. What is the direction of del F? Sir, this is the direction of del F. And what is the direction of del? This is the direction of del. Between them, there is a dot product. Cos 0 is 1. So it will come out to be del square F. It actually comes out to be del square F. Okay. So just simply remember there are only two null identities, that is CG and DC are 0. That's it. Okay. Let's solve this question. Very interesting question it is. Try solving it on your own. Think about it and you will be able to solve it. Very interesting question. Then after this question, we need to solve this particular question and this particular question. Two questions are there. Okay. And after that, this last question. Not last. More questions would be there. But yeah. Try thinking of this question on your own. I will take a break, drink some water and I will come back. Just think of it. Option B and option D are interesting. This we already know. If it is solenoidal, then it is 0. If it is irrotational, then it is also 0. B and D are interesting. So think about it and you will be able to understand. Have some patience and try solving it. Okay, let me take a break and then I will come back. Yeah, welcome back. So did you solve this question? Look, what is given? Vector field is irrotational. Vector field F is irrotational. Then what will happen? So what is given? Given is that vector field F is irrotational. If F is irrotational, then you already know that del cross F equals to 0. Now what do I know? I know two identities, sir, that CG equals to 0 and DC equals to 0. Delhi Capitals 0, CG equals to 0. That means curl of gradient is 0. And divergence of curl is 0. These thing I know. Now let's talk about this one. Curl of gradient. What does that mean? That means you will take the curl of some gradient. Curl of gradient is 0. That means you already know that, sir, curl of some gradient is 0. What does that mean? That means your vector field F could be written as gradient of some scalar field. Say yes or no. Do you agree to this point or not? That's it. This is what has been written. That if your vector field is irrotational, then your del cross F would be 0. That means F could be expressed as the gradient of some scalar field or scalar potential. Is that understandable to you or not? This statement is true. If a vector field F is irrotational, then del cross F would be 0 and F could be replaced as the gradient of some scalar field. This is what has been written. Next, if F is solenoidal, that means del dot F equals to 0. So from here what you can see, divergence of curl is 0. Divergence of curl is 0. First you need to calculate the curl, then you need to take the divergence, that is equals to 0. So from here what you can see, that sir, divergence of curl of A equals to 0. So from here if you compare, F is coming out to be same as del cross A. That means if your vector field is solenoidal, then you can write down F as del cross A. So if your vector field F is solenoidal, then it can be represented as the curl of another vector. That means option D is correct. So for these kind of question, only two things you need to remember: DC equals to 0, CG equals to 0. That's it. Then you will be able to write down, sir, curl of gradient, divergence of curl. Then you see what is given. Del cross F is given. So from here what do you know? Curl of gradient is 0. That means del cross del phi is 0. So F is equals to del phi. Right? And then divergence of curl is 0. That means if divergence is 0, so F could be written as del cross A. Now this kind of question could be coming in the examination hall. What I framed here, this kind of question will not come in the examination hall because it is a straightforward statement. But this kind of question could be coming in your examination hall. Okay. So which of the following vector field can be expressed as the curl of another vector field? What they are asking? Out of these vector fields, which of the following vector field could be replaced as the curl of another vector field? Vector field is replaced as the curl of another vector field. For which of them it is possible? This is what they are asking. That f could be replaced as del cross A. What do you know? Sir, I know two things. Divergence of curl is 0. Curl of gradient is 0. What is the meaning of divergence of curl is 0? Divergence of curl is 0. Divergence of curl is 0. And another thing I know, curl of gradient is 0. Curl of gradient is 0. Now if I say del dot f equals to 0, if I say del dot f is equals to 0, then what you can say? F could be replaced as, if del dot f is 0, then f could be replaced as del cross A. This we have seen, no? If del dot f is 0, then f could be replaced as del cross A. F could be replaced as del cross A. You don't need to mug it up, but can you remember it? Somehow can you? You don't need to mug it up, but will you be able to derive it? That these kind of questions are coming, sir. Curl of another vector field, something with the null identities it is related. Divergence of curl, curl of gradient. You wrote down both of the things. Then you thought one thing, that sir, if I keep del dot f equals to 0, then f could be replaced as del cross A, and this is my requirement. That means what this question is asking? This question is simply asking, for which of the following options, del dot f equals to 0. This is what the question is asking. For which of the following option del dot f is 0? That's it. This is the bottom line. This is what this question is asking. So you need to calculate del dot f, and you need to see whether it is 0 or not. So option A, what is del dot f? This will be differentiated with, I am calculating del dot f. So I cap part will be differentiated with x 0, 0. It is 0 only. Option A is correct. Option B, do I need to calculate del dot f? No sir, del dot f is nothing but r only. It is the position vector. Sir, it will be equals to 3 only. I already know. So this is not correct. Then option C, del dot f I am supposed to calculate. So first you need to differentiate with respect to x 0, with respect to y 0, with respect to z 0. It will be 0 only. Option C correct. And option D, del dot f, differentiation with respect to x 2, differentiation with respect to y minus 1, differentiation with respect to z minus 1. What is the answer? 0. This option is also correct. So how will you think in the examination hall? What they are saying, that which of the following vector can be expressed as the curl of another vector? So first of all you write down the vector should be replaced as curl of another vector. Curl of another vector. Then you go to these identities. Then you go to know that, yes sir, vector f, if I want to write down as del cross A, that means del dot f equals to 0 I need to make. That's it. Second question, try solving on your own. What they are asking, which of the following vector could be expressed as a gradient of some scalar field? That means f should be replaced as a gradient of some scalar field. Gradient of some scalar field. This is my requirement. This is my requirement. Which of the following vector could be replaced as gradient of some scalar field? What do I know? I know these two things, dc equals to 0, cg equals to 0. Divergence of curl, curl of gradient. Divergence of curl, divergence of curl, and curl of gradient. So if I say my del cross f is 0, if I say my del cross f is 0, if my del cross f is 0, then from here what you can say, that sir, f could be replaced with del phi. So what is your question? For which of the following statements del cross f equals to 0? This is the question that they are asking. For which of the following options del cross f equals to 0? This is what they are asking. That's it. So if del cross f is 0, then f could be replaced as del phi. And if del dot f equals to 0, then f could be replaced as del cross A. Is that understandable to you or not? Absolutely sir, completely understandable. So I just need to find out for which of the following option del cross f is 0. So what is option A? Option A, f is given nothing but 2 r vector. Say yes or no? It is 2, I take outside 2 r vector. Now do I remember del cross r? So that would be 0 only. What does that mean? Del cross 2r will also be 0. 2 is just simply constant value, no? Although it is not correct. That you cannot write down, it would be 0 as well. Although it will come out to be 0 only. So you calculate del cross f. Okay. For the first one you calculate del cross f, you would see that del cross f is also coming out to be 0. You can calculate it. it will come out to be 0. Like basically del cross, let's just say there is some function f and vector a. So how it could be written? You can take f outside. Directly you cannot take f outside. There is some formula that we will see. But if it is a constant value, no, let's just say if it is some 3, let's say it is 3, then 3 directly you can take outside. So basically, like if you are writing no del cross 2r vector, then 2 you can take directly outside. 2 you can take directly outside. So what you will be getting? Del cross r. So that would be equals to 0 only. Okay, so from here, because del cross r is 0 only, no, so 2 into 0 will be 0 only. So from here you can write down that del cross f will come out to be 0. But just it is constant, that's why you can take outside. If it was a function of x, y, z, no, then you couldn't then you could not take it outside. There is a separate formula for that. We will learn that formula. But constant value you can take outside. So answer will come out to be 0 only. There you go. Okay. So first one is the correct option. Second one, you calculate del cross f. I cap, j cap. It will not come out to be 0. Okay, I can directly see. Let's calculate del cross f for the second option. Del cross f for the second option. Let's calculate. Del by del x, del by del y, del by del z. Y minus x 0. For I cap 0 would come, minus j cap 0 would come. For k cap minus 2 would come. So minus 2 k cap it is. It is not equals to 0. So del cross f is not equals to 0. This option is wrong. For the last one, option C, not last one, second last, del cross f. I cap, j cap, k cap, del by del x, del by del y, del by del z. Y plus z, x plus z, x plus y. Y plus z, x plus z, y plus z, x plus z, x plus y. I cap 1 minus 1 0 minus j cap 1 minus 1 0 plus k cap 1 minus 1 0. You are getting 0 only. Okay, you can do the calculation. Everywhere the differentiation is coming out to be same. 1 minus 1 0, 1 minus 1 0, 1 minus 1 0. It is coming out to be 0 only. Okay, and next last option, del cross f. yz xz xy, yz xz xy, yz xz xy. I cap x, then partial differentiation with respect to z will also be x only. So x minus j cap y minus y plus k cap z minus z. So yes, it is coming out to be 0 only. So this option is also correct. C and D both are correct. B is not correct. So these kind of question you need to have some patience, you need to think, and your job would be done. Patience, thought process, everything will be solved. Otherwise, people will not even be able to understand what they are asking. These kind of questions will not even click to the students in the examination hall. But if you want to solve these kind of problems in the examination hall, you need to have some patience, and for sure that these kind of question would be coming from null identities. Two null identities we are having, DC equals to 0, CG equals to 0. With that, everything you will be able to solve. So always remember, if curl is 0, if curl is 0, if you try to remember, like in a longer run, you would be able to remember it. If curl is 0, no, then f could be replaced as del phi. And if gradient is 0, then f could be replaced as del cross E. Is that understandable to you? Okay, these two things, if you are able to remember, then it is good for you. If divergence is 0, then f could be replaced as del cross A. If curl is 0, then vector field could be represented as gradient of phi. Okay, so these two things, if they are there in your mind, then your life would be a bit easier. Otherwise you can get it from null identities as well in that manner. Okay, next question. Again R is given, you need to calculate all these things. This time I'm asking about Laplacian, Laplacian and Laplacian. Okay, this you already know, gradient it is. Gradient of fr. What is the answer? First differentiate with respect to r, then r cap. So what will be gradient of r square? Differentiate with respect to r, then r cap. Differentiate with respect to r, then r cap. This could be one of the possible option mentioned, or they can write down r vector divided by r. So answer would be 2 r vector. Because what this is? Magnitude of r multiply with magnitude of r with having the direction of r cap. So r into r cap will be r vector only. So this could also be mentioned. This could also be mentioned. One of the option will be mentioned. Most probably this option will be mentioned. So 2 r cap, 2 r vector will be the answer. Understandable? How will you solve this one? Del square fr. How will you solve this one? Del square fr. Look sir, how the formula came, that I can tell you later on. Okay? How the formula came, I will tell you in this lecture only. Have some patience. But you need to remember the formula. What you will do? First of all, you will differentiate the function with respect to r. First, you will differentiate the function with respect to r. Then you will multiply r square. Then you will multiply r square. Then you will again differentiate with respect to r. Whatever the answer that you have got here, whatever the answer that you have got, then you will again differentiate with respect to r. Then divide by r square. What is the process? That sir, I was having fr. What I will do? First, I will differentiate with respect to r. Then some answer I will get, f dash r I will get. Then I will multiply r square. What I will get? R square f dash r. Then sir, again whatever the answer that I have got, no, I will differentiate that answer with respect to r again. Whatever the answer that I have got here, then I will differentiate it with respect to r again. Then I will differentiate it with respect to r again. And then sir, whatever the answer that I get, I will simply divide it by r square. Simply divide it by r square. There you go. This is the process we need to follow. So if you are supposed to calculate the Laplacian of ln r, Laplacian of ln r, Laplacian of ln r, how will you calculate Laplacian of ln r? What is the process? So the process is that first I will differentiate ln r. What I will get? 1 by r. Then sir, I will multiply with r square. What I will do? I will multiply with r square. What I will get? R only. Then I will again differentiate it. Again differentiate. What answer I am getting? R I am getting, no. So I will again differentiate it with respect to r. What answer I will get? 1. And then I will divide by r square. So what will be the answer? 1 by r square will be the answer. Again let me repeat what we are doing. First, differentiation with respect to r. Like del square ln r I need to calculate. So differentiate with respect to r. That would be 1 by r. Then multiply with r square. Then multiply with r square. Then whatever the answer that you are getting, differentiate that with respect to r again. And then divide by r square again. So what you are getting here, r get cancelled out, this will become r only. Del by del r is 1. So answer you are getting is 1 by r square. That's the answer that you are getting. Say yes or no. Let's try another way. Del square ln r, right? Del square ln r. Do you remember what was del square? How this came? I hope you remember it. So it was nothing but del dot del ln r. Del dot del ln r. Can you calculate this del ln r? Can you calculate the gradient of ln r? Yes sir, it will be nothing but 1 by r r cap. Absolutely sir, it will be nothing but 1 by r r cap. Del dot 1 by r r cap. Now can you write down r cap in some different way? Can you write down r cap in some different way? So that will come out to be r vector divided by r. So sir, it will come out to be r vector divided by r square. Now this is what we are supposed to calculate. You are supposed to calculate the divergence of r vector divided by r square. What it would be? What will be your r vector divided by r square? R vector divided by r square. Sir, r vector is nothing but x I cap plus y j cap plus z k cap divided by x square plus y square plus z square. X square plus y square plus z square. Now you need to calculate the gradient. So in gradient, what do? You partially differentiate this function with respect to x plus partial differentiation this function with respect to y plus partial differentiation of this function with respect to z. This is what you will be doing. So it will be a tough process, right? But let me tell you one thing. This formula we are going to write down later on again. Okay, what is that formula? Del dot some scalar function multiply with the vector field. Scalar field multiply with the vector field. Let's just say f is some x, y, z. A is some x I cap plus y plus z k cap plus 3x. This is j cap and this is k cap. So this is your f is scalar field function and a is your vector field function. So how will you calculate that divergence? If you multiply f with a, what will happen? Sir, x, y, z will be multiplied with x. It will become x square y z I cap plus x, y, z multiply with y plus z. It will become something j cap. Then x, y, z multiply with 3x. It will become something k cap. So it will become a vector field only, no? So you are calculating a new vector field which is b vector. So you are calculating the divergence of b vector. So what that would be equivalent to? So that would be equivalent to, what you do is that first you take this f outside. So what you will be getting? If I take f outside, then inside what I will do? I will calculate the divergence of a. Plus, now what you will do? You will keep a aside. And now you will treat f with the del. So what you will be getting? Gradient of f. Are you able to understand this point? Basically what they are saying is that divergence of f multiplied with vector a would be given as f outside divergence of a, f outside divergence of a plus vector a dot gradient of f. This is what it could be given. Now what is the scenario? You are supposed to calculate the divergence of 1 by r square r vector. Now what will happen? 1 by r square will come outside. 1 by r square will come outside. Del dot r vector. Now what you will do? You will take r vector outside. You will take r vector outside, and now you will treat. You will take r vector outside, and now you will treat del with 1 by r square. Is that understandable to you? So now can you solve this one? Yes sir, this will give me the answer of 3. Can you solve this one? Del 1 by r square. What answer it will give you? Sir, it could be written as del. It is not dot product. Okay, you are simply calculating the gradient. It is not a dot product. You are calculating the gradient of r to the power minus 2. What will be the gradient of r to the power minus 2? Gradient of fr. Differentiate, keep r vector. Differentiate, keep r vector. So what answer you will be getting here? You will be getting minus 2 r to the power minus 3 r cap. So when you solve it completely, what you are getting? 3 r to the power minus 2, 3 r to the power minus 2 minus 2 r to the power minus 3 r cap. अरे यार मीटिंग थी यार एक, r cap r vector, right? So r cap r vector, how r vector could be written? This r vector could be written as r cap, right? So here what we will be getting? 3 r to the power minus 2, 2 r to the power minus 3 r cap dot r cap, right? So r cap dot r cap will become 1 only, and this is r only, so this will become 2 r to the power minus 2. So 3 r to the power minus 2 minus 2 r to the power minus 2. The answer we are getting is 1 by r to the power 2. I hope you are able to understand this much, yaar. Minus 2 r to the power minus 3. This is your r vector. So r vector will be dot product with what? R cap only, no? So r vector dot product with r cap. What answer you will be getting? This you already know. R vector could be written as r with r cap. So r vector is written as r with r cap. So this r is constant. So r will be multiplied with r to the power minus 3. This will become r to the power minus 2. Now r cap dot r cap will become 1. So what we are getting? 3r to the power minus 2 minus 2r to the power minus 2. That would become r to the power minus 2. Or answer is 1 by r square. Otherwise, you just simply remember this process and you will get your job done, right? Now del square r to the power n. This you try to calculate on your own. Del square r to the power n. You try to get this answer on your own. What is the process? You already know. that first you differentiate, then multiply with r square, then again you differentiate, then divide by r square. I will take a meeting. I forgot it actually. Then I will again come back and we will get started with it. Okay. Yeah. Okay. So you try doing it on your own. I will come back within a minute. Yeah. Welcome back, guys. So sorry for the interruption. So were you able to solve this question? First of all, you let me know were you able to understand this question? That this was the method, sir. This was the method that we understood. That first you differentiate with respect to r. First you differentiate with respect to r, then you multiply with r square, then multiply with r square, then whatever the result that you are getting, then again differentiate it with respect to r, again differentiate with respect to r, then divide by r square, then divide by r square. This is the final result. Differentiate with respect to r, multiply with r square, then again differentiate with respect to r, then divide by r square. This is what we have understood here. Understandable? And this is the general formula, but we don't remember the formula, we remember the process. After that, sir, we derived it as well. Del ln r we calculate 1 by r cap. This could be written in this way. Now after that, what I will do, I use this identity. Okay, this we are going to learn further as well, but this is the identity that we are using here. What is that, sir? F a vector. That means it is a scalar multiply with the vector. So f will come outside del dot a plus a vector will come outside del f, because del dot f you cannot do. Del dot f will not make any sense because f is a scalar. So you can calculate the gradient. So gradient dot product with a. That's it. Understandable? This is what I am going to do. So the same thing I have applied here and I got the answer, which is 1 by r square. I hope it is not very much difficult for you. Here it is 1 by r square coming outside. This answer will be 3 by r square. Then here what you can see is that this r vector is coming outside. So del 1 by r square. This is gradient of 1 by r square. So you will get the answer. Gradient of 1 by r square will give you minus 2 r to the power minus 3 r cap. So minus 2 r to the power minus 3 r cap. Already there is dot product with r vector. So basically r cap multiply with r vector. What that would be? R vector could be written as r cap. So this is direction only, r is the constant value. So this will give you answer 1 only. So r cap dot product with r vector will give you answer as r only. So what this will become 2r to the power minus 2. So 3r to the power minus 2 minus 2r to the power minus 2 will become 1r to the power minus 2, or you can write it down as 1 by r square. Understandable? Very much understandable. Let's solve this one with the simple formula. What formula says? That first you differentiate r to the power n. What you will be getting? N r to the power n minus 1. Then you multiply it with r square. What you will get? When I multiply with r square, I am getting r to the power n minus 2 plus 2. Sorry, r to the power n minus 1 plus 2. Then it will become r to the power n plus 1. Then multiply with r square, then again differentiate it. Again differentiate it. What you will be getting? N into n plus 1 r to the power n, and then divide by r square. So this is the final answer that you are getting. This is the final answer that you are getting. There you go. Again, let me write down the process again. R to the power n was there. First, what I will do, I will differentiate it. First, I will differentiate it. What I will get? N r to the power n minus 1. Then multiply with r square. Then multiply with r square. N r to the power n plus 1. Then again differentiate it. Again differentiate it. N plus 1. 2 time differentiation we are doing. Okay. And then divide by r square. So here it was multiply with r square, then again differentiated, 2 time differentiation, 1 time multiplying with r square, another time dividing with r square. So what is the final answer? N into n plus 1 divided by r square means r to the power n minus 2. So follow the process line by line. Just remember this process and your job is done. Usually I don't ask to remember the formula, but this kind of questions have been asked in the examination again and again. Again and again these kind of questions are asked. So that's why I am asking you to remember this. Otherwise, I would prefer this particular scenario. No? In the examination, eventually you are going to remember this identity. Okay. So you would prefer this particular thing, but again and again such questions are asked. So they are also expecting that you remember this process. The process is very simple. First differentiate, multiply with r square, then again differentiate, divide by r square. That's it. Okay. So this was your Laplacian. Next, till this point we have applied Laplacian operator on a scalar quantity. This is a scalar quantity. This is a scalar quantity, right? It is a scalar quantity only, no? Because it is r. What is r? R is under root x square plus y square plus z square, right? So we have applied it on scalar quantity only. But Laplacian could be applied on vector quantity as well. So definition will change. What was Laplacian? Laplacian was, sir, del dot del only, no? This was Laplacian. So sir, how I can apply it on vector quantity? You can apply, have some patience. This is your vector f, right? Can I write down vector f as f1 i cap plus this is your f1, right? Although it is a function of xy, but I am just calling it f1 i cap, f2 j cap plus f3 k cap. I hope you know what is your f1, f2, f3. F1 is nothing but x square y plus z cube. F2 is nothing but y square z plus x cube, and f3 is nothing but z square x plus y cube. What you are supposed to calculate? You are supposed to calculate del square f. Can I write it down in this manner? Del square, what is my f? F is f1 I cap plus f2 j cap, f3 k cap. What you are getting from here? Del square f1 I cap, del square f2 j cap, del square f3 k cap. Is this a valid operation? Yes, sir. Del square f1 is a valid operation, no? F1 is a scalar. Can you apply Laplacian operator on a scalar? So eventually you are applying Laplacian operator on a scalar only. But how did you make it? You made in this way: del square f1 I cap, del square f2 j cap, del square f3 k cap. So eventually you are applying Laplacian operator on a scalar only, Laplacian operator on a scalar only, Laplacian operator on a scalar only. So now your target is to calculate del square f1. What that would be? So that would be nothing but partial differentiation with respect to x 2 times, partial differentiation with respect to y 2 times, partial differentiation with respect to z 2 times. So f1 will be partially differentiated with respect to x 2 times. So what he will be getting? 2xy, then again differentiate 2y plus partial differentiation with respect to y 2 times, partial differentiation of this guy with respect to y 2 times. So first you will differentiate with respect to y, so you will be getting x square only, then you will be getting 0. Then partial differentiation of this function again with respect to z 2 times. So what you will be getting? 3z square one time and then 6z. So what you are getting? 2y plus 6z. 2y plus 6z. Now del square f2 we need to calculate. So what will be the answer? Same thing, del square by del x square f2, del square by del y square f2, del square by del z square f2. So partial differentiation of this function with respect to x 2 times. What answer you will be getting? You can directly see, sir, this will be 0, 6x I will be getting, plus partial differentiation of this function with respect to y 2 times. What you will be getting? 2yz and 2z. 2z you will be getting. And partial differentiation of this function with respect to z 2 times. What answer you will be getting? First y square, then 0. So what answer you are getting? 6x plus 2z. I hope you are able to understand. Then del square f3. Del square f3. Just follow process by process. Everything is simple, sir. F I can write down in this way. Del square f I need to put. That means, sir, del square on this operation, del square on this, and del square on this. This is how I am doing it. So I am not changing the definition as well. Del square is applied on the scalar quantity only. Del square f1, del square f2, del square f3. Are you able to understand this point? But you can apply it on a vector as well. This is how you can apply it. It is an operator which can be applied in this way. Are you able to understand this point? Okay. Del square f3, del square f3, del square f3. So when you calculate del square f3, here I am getting 2y plus 6z, here I am getting 2z plus 6x. So partial differentiation of this function with respect to x, what you will be getting? With respect to x you are doing, right? So z square 0 you will be getting. Partial differentiation of this function with respect to x, you will be getting 0. Partial differentiation of this function with respect to y, you will be getting 6y. And partial differentiation with respect to z, you will be getting, with respect to z you need to do, no? So x will come outside, you will be getting 2x, right? You will be getting 2x. So this is coming out to be 2x plus 6y. So eventually what answer you are getting? Del square vector f. Del square f. What is your del square f? So del square f, sir, I am getting is this quantity which is 2y plus 6z I cap, 2y plus 6z I cap, plus, sir, next quantity is 2z plus 6x, 2z plus 6x j cap plus 2x plus 6y k cap. Usually it is not asked in the examination, but who knows where it might be used. So eventually what conclusion you have made? That, sir, del square, if I apply on a scalar quantity, del square phi, this answer will be scalar as well. And sir, if I apply it on a vector quantity, then answer is vector only. Okay, so this is how you can apply Laplacian operator both on vector and scalar without changing its definition. This is the definition which is absolutely correct without changing that definition. Understandable? So completely clear. Next, very important identity we need to see. Do you remember A cross B cross C? In your class 11, 12th, you might have studied A cross B cross C. Do you remember it? What was the result of A cross B cross C? How you used to remember? That sir, A and C are far away. A and C are far away. So first A and C will meet. First of all, you let me know what will be the result of A cross B cross C. Sir, B cross C is nothing but vector only. Vector, vector, cross product is this will be vector only. Now vector cross product with vector. So sir, result will be vector only. So result is coming out to be vector. That is fine. So A dot C, then B will come as it is. A dot C will give you scalar quantity. Let's just say A dot C gave us a 3. Then 3 multiply with B vector. What is this? This quantity is a vector only. Then what will come? Minus sign will come. Then now A will go and meet B. Because B is closer away. No, the one which is far away, that is more loud one, right? So first A will go meet C, A dot C. Then B will come as it is. Then A will go and meet B. So A dot B. Why it is meeting C? Because it is far away. So one which is far away, we will try to meet them first, right? This is closer only, so A dot B, C, right? So ACB, ABC, it will not be a way to remember, but far away A dot C, then B, minus A dot B, then C. Although this will not be asked in your examination, what will be asked? This will be asked, that you need to calculate curl of F. This is what you need to calculate, curl of F. Understandable? So let's try doing it. Curl of F. Is it a null identity? CC is not a null identity. So first of all, you let me know, is it a valid operation? Sir, curl of F, what it will give you? Vector. This is also a vector. So between vector and vector, can you do the cross product? Absolutely, sir. Vector cross product with vector, it will give us a vector answer only. Okay. So now we are supposed to calculate del cross F. What I will be getting. So first of all, this del will go and it will talk to this F only. So del dot F. Then multiply with this del. Minus. Then this del will go, it will talk to this del only. Del dot del. And then simply multiply with F. Is it a valid operation? So del dot F will give me a scalar quantity. And then sir, this is an operator. So do I write down in this manner? No, I write down d by dx of x. This is the correct way, no? So what you will do? First you will write down the operator and then the scalar quantity. Minus del dot that will give you del square F. There you go. This is the answer of del cross F. This is the answer of del cross F. That's it. Do you need to mug it up? Absolutely not. Usually student remember it, but will you be remembering it? Absolutely not. You will be deriving in this way. So del cross F. So this del will go and talk to F, del dot F, then this del will come. Minus this del and this del will talk with each other, del dot F. This will become del square F only, sir. What about this guy? Sir, this is not a correct way of writing because this is an operator, sir, and this is a scalar quantity. So operator should come before and it will be, and then we will write down the scalar quantity. Now, this is a scalar and this is a del operator. What you are doing? This is gradient of divergence of F. If I need to write down in theory, what I am doing? Gradient of divergence of F. Divergence of F. You are calculating the divergence of F first and then you are taking its gradient minus Laplacian of F. Laplacian of F. So now you let me know, is it a vector quantity? Yes, sir. Is it a vector quantity as well? Yes, sir. Gradient will always give the vector answer, no? This is GD, gradient of divergence. Is it a null identity? No, there is only two null identities, sir. DC is 0 and CG is 0. So divergence of curl is 0 and curl of gradient is 0. Gradient of divergence is not a null identity. So it will give you some results. Whatever the result it will give you minus Laplacian of F. There you go. Directly question have been asked on this particular formula that they will give you del cross F, what it will be equivalent to. So it will be equivalent to this guy. One of the option will be mentioned, you need to click on that option. Is that understandable to you? Completely understandable, sir. Okay, so you need to click on that particular option, whichever is mentioned in the options. Let's just say vector field F is given. Okay, in the examination, this field is given. And they are asking us del cross F. Do you really think that I will apply this formula? This is given. And they are asking del cross F. I will first calculate this guy. Then whatever the vector I am getting, then I will again calculate del cross Let's just say after calculating this, I got A vector. Then I will calculate del cross A vector. So if vector field is given and they are asking this particular thing, then I don't need to apply the formula. But in the examination, they can ask that which of the following statements are true. Option 1, del cross F equals to this formula. So that you need to click on. So formula should also be there in your mind. But in the examination, if field is given and they are asking this question, then why would I apply the formula? Why I need to make the things complex for me? I will not apply the formula there. I will simply calculate the answer. But who knows, in the examination, directly they are asking the formula. So sometimes they can directly ask the formula. That's why we are writing down the formula. Understandable? Now some important identities we are going to see. So what we are going to consider: F as a scalar field, G as a scalar field, and A as my vector field. This is what we are going to understand, and three important identities we are going to see. Okay, F is my scalar field, G is my scalar field, and A is my vector field. So forget about these formulas. I will write down the formula in our own way, and I will tell you the way to remember it as well. First of all, you let me know F into G will be a scalar field or not. F multiply with G. This is the multiplication, F into G. Scalar field multiply with scalar field. Let's say F is x, y, z, and G is xy plus 2z plus 3xyz. So both being multiplied, it will be a scalar field only. So F into G will be a scalar field only. It will be a scalar field only. So you are calculating the gradient of a scalar field. Gradient of a scalar field. Gradient of a scalar field. So what will be the answer? Sir, first as it is gradient of second plus second as it is gradient of first. Gradient of any scalar field, what will be the result? Sir, it should be a vector only. Now, what will be the result here? It will be a vector. Vector multiply with the scalar. Vector multiply with the scalar will be a vector only. This will also be a vector. Vector multiply with the scalar will be a vector only. So vector plus vector will be a vector only. Yes, sir. So this is very simple, no? You are calculating the gradient of F into G. So first as it is gradient of second plus second as it is gradient of first. This is first formula. The second one, you are calculating del dot Fa. This we have already seen. So what I will do first? First I will take out this F. First I will take out this F. Don't look here, okay? Just see this formula. First I will take out this F. Then what I will do? This del will be operating with A, del dot A, plus. Then what I will do? Now del will say that I will operate with F. Del will say that I will operate with F. So how it will operate? It will take the gradient, because it cannot do the dot product. No, here dot product is not possible because F is a scalar field. Now it will become a vector. So dot product with the vector A. This is your vector A. This is your vector A. So dot product with vector A. This is the answer that has been written here. What you will do? First you will take out F. F I have taken out. Then del will say that I will operate with A, del dot A, plus. Then now del will say that I will operate with F. So with respect to F, what you can do? You can only calculate the gradient. You cannot do the dot product. So I calculated the gradient. Then dot product is there. So dot product with A vector. That's it. Understandable? Very easy, very straightforward. This is the result. Now talking about vector or scalar. So if you calculate the gradient, if you are calculating that divergence, divergence will give you a scalar quantity. Divergence will give you a scalar quantity. This is also scalar. Scalar multiply with scalar will be scalar only. Scalar multiply with scalar will be scalar only. What is this? This will be vector. Vector dot product with vector. Vector dot product with vector will give you scalar only. So scalar plus scalar will give you scalar. Scalar and vector dot product with vector will give you scalar. So scalar plus scalar will give you scalar only. I hope it is very much understandable, although it is not required to tell, but still I am telling so that you will be comfortable. F you take outside, del dot A plus what you will do? This time you will treat F. So del F dot A vector. Similar with del cross Fa as well. What you will do when you talk about del cross Fa? I need to talk about del cross Fa. F A vector. What I will do? F you take outside. F you take outside. Then del cross A plus. Look, F you have taken outside and simply del is treating with A. Now what del will say? That I will treat with F. I will treat with F. So del with F, what it can do? It can only calculate the gradient. Now will it become a vector quantity? Yes. Now this vector quantity will be cross product with A. Look, here there is cross product. No, so everywhere there is cross product only. Here there is dot. So everywhere here is also dot product. Here also dot product. Here there is cross product. So what will happen? First F will say that I am a scalar. I will get out del cross A plus. Now what del will say? That I will operate with F. So del F, because it can only calculate the gradient. So del F. Now it will become vector quantity. Now since there is a cross product, so A will say that do the cross product with me. So this is the next answer that you are getting. This is the next answer that you are getting. That's it. Okay. So these are the three identities that we are supposed to remember. This is the first one. This is the second one. Now here you see on your own, will it be a vector quantity? Cross product with this is vector, this is vector. Yes, sir, it will be a vector quantity. What about this one? Is it a vector? Yes, sir. Vector multiply with scalar will be vector only. Now, is it a vector? Yes, sir. Vector cross product with vector will be a vector only. And vector addition with vector will be a vector only. So, yeah, both sides you are having vector only. Now, let me know one thing. If f is a constant value, if f is uniform, I should not say uniform. There is difference between uniform and constant. Okay. Let me tell you what is the difference between uniform and constant. Uniform versus constant. What is the difference between both of them? Uniform means that it is not a function of a coordinate system. That means it is not a function of x, y, z. And what is the meaning of constant? That it is not a function of time. Let's just say some field I am writing down 2t I cap plus 3j cap. Is it uniform? Yes, it is uniform. It is surely uniform. Is it constant? No. Why is that so? Because it is a function of time. Now another field I am writing down, which is 3x I cap plus 7j cap. Is it uniform? Is it uniform? No. Why is that so? Because it is a function of x. Is it constant? Is it constant? Yes, because it is not a function of time t. And another field I write down 3 I cap plus 4j cap. So it is neither a function of space nor it is a function of time. That means it is uniform as well and it is constant as well. People think that both of the statements are same, but they are different. Okay. Understandable? Now I am saying that f is uniform. F is uniform. Can you let me know what will be the value of a gradient of f? What is gradient of f? So gradient of f is nothing but I cap, j cap, k cap, right? And you know that if f is uniform, what does that mean? That means f is not a function of x, y, z. It is not a function of x, like f could be 3t. If you differentiate 3t with respect to x, what will be the answer you will be getting? 0 plus 0 plus 0. What will be the answer? 0. So if f is uniform, then the answer that is coming out to be, for gradient of f, answer will come out to be 0. So if f is uniform, then your del cross f a vector could be written as what? This will be 0. This will be del, this gradient of f is coming out to be 0. 0 multiply with anything will be 0 only. So how it can be written that directly, sir, f is coming outward. Directly f is coming outward, del cross a. This is the answer. If f is uniform. If f is uniform. If it is not uniform, then the complete answer you need to write down. And if f is uniform, then what about del dot fa? Sir, the actual answer of del dot fa was that f comes outside del dot a. Then, sir, this operator will say that I will deal with f dot a cap. Now, since this is 0, so 0 dot product with anything will be 0 only. So this term will be gone. So if f is uniform, then these are the answer you will be getting. Here, what was the actual answer? Sir, f comes outside del cross a plus now del will say that I will deal with f cross product with a. That's it. This cross product will be done with a. Now this is 0, so this will be gone. This term will be gone. Only if this will be happening, only if your f is uniform. Because when f is uniform, then its gradient will be 0 only, which is pretty obvious because it is not a function of x, y, z. So these kind of things are written in the class notes. Always people try to mug it up, but for every single thing I am giving you, every single reasoning as well. Like everything is crystal clear. I am giving 0 pressure on your brain. Only one pressure I am putting up, which is this method. Which method? This method. That first you differentiate with respect to r, then multiply with r square, then divide by, then you again differentiate with respect to r, then divide by r square. For this as well, I have given you the derivation that this is how the formula is derived. But eventually in the examination, you cannot follow this process. This will be very lengthy. So what we will do in the examination hall? In the examination hall, sir, we will be preferring what? We will be preferring the method that you have given us. Okay. Such kind of questions could be asked in the examination hall. Try solving it. First one, calculate del dot r to the power n r vector. First of all, you let me know what is r to the power n. Is it scalar or vector? Yes, it is a scalar field. R vector is a vector field. function of R scalar field. What is the meaning of R to the power n? R to the power n simply means under root. What is R? Under root is R is under root x square plus y square plus z square to the power n. This is the meaning of R to the power n. Okay, this is the meaning of R to the power n. So it is surely a scalar quantity only, right? So first of all, what I am supposed to calculate? First, I am supposed to calculate del dot R to the power n R vector. This is what I am supposed to calculate. What will be the answer of it? Sir, this is a scalar, it will come out. R to the power n will come out. Then sir, del will deal with del dot R we will do plus, then del will say that I will deal with R to the power n dot product with R cap. Now what is the result of del dot R? So that is nothing but 3 R to the power n. What is the result of this? 3 plus, let's not write down here, del dot R is 3. So now what is the result of del R to the power n? The result of del R to the power n is n R to the power n minus 1 R cap dot R vector. Now here I am writing down the result of R cap dot R vector. Okay, what that would be? R cap dot, what is R vector? R cap, right? Magnitude and direction. R comes outside, R cap dot R cap will be 1, that is equals to R only. So always remember this particular thing will be equals to R only. 3 R to the power n plus n R to the power n minus 1 dot R. What you are getting? This will be R only, so here I have written R. 3 R to the power n plus n R to the power n. What answer we have? 3 plus n R to the power n. So for the first question, del R to the power n R vector, the answer we are getting is 3 plus n R to the power n. Don't try to mug it up, try to derive it in the examination hall. Understandable? Next one, del cross R to the power n R vector. I hope no error is there. Again, let me recheck. This goes here, then deal with this n R to the power n minus 1 R vector R vector. So this will be R only, R to the power n only. So 3 plus 1 R to the power n. Yes. So del cross R to the power n R vector. Next is del cross R to the power n R vector. Del cross R to the power n R vector. So this R to the power n goes outside. R to the power n goes outside. Right? This will say that I will deal with R vector. Then del will say that I will deal with R to the power n, then cross product with R vector. Understandable? R to the power n goes outside, del cross R, then R to the power n will say that I will deal with del, so directly deal with del, then cross product with R vector. Now, what is the result of this? 0, right? Del cross R. I hope you remember it. Del dot R equals to 3. Del cross R equals to 0, right? So this result is 0 only. So 0 R to the power n will be 0 only. Now what is the result of this? The result of this would be n, this will be 0 plus n R to the power n minus 1 R cap cross with R vector. Let me know what will be the result of this. What is the result of gradient of R to the power n? That will be n R to the power n minus 1 R cap. R cap cross product with R. R cap cross product with R. Both will be in the same direction, no? This is your R cap and this is your R. Angle between them is, whatever the magnitude you get, angle between them is 0 degree. So what is sine 0? That is 0 only. So what will be the result of this? That will be 0 only. So 0 multiplied with anything will be 0. What is the answer? 0. So what is the answer of second one? Del cross R to the power n R vector. What is the answer? Answer is nothing but 0. Next question. Del dot fr R vector. Del dot fr R vector. So fr you take outside. Fr you take outside. Then del dot R. Look, this is not a dot product, okay? This is simply multiplication. Fr you take outside, del dot R. Del dot R. Plus what you will do? Now, del will say that I will deal with Fr. Del will say I will deal with Fr. Dot product with R vector. Now, del dot R will give you 3. So, 3 F of R. Plus, what this will give you? Del Fr. Gradient of Fr. That will give you F dash R R cap dot R vector. F dash R R cap dot R vector. What this will give you? This will give you nothing but R only. Just keep it in a box so that you remember. R cap dot product with R vector will give you nothing but R. So this is giving us nothing but R only. So what it is giving us? 3FR plus F dash R. That's the result. That's the final result of this. Okay. You don't try to remember it. Simply derive it in the examination. So here if you see this question, no, 3FR, you write down 3FR plus F dash R, which is nr to the power n minus 1, nr to the power n minus 1 multiply with R. So 3r to the power n plus nr to the power n. So 3 plus n r to the power n. Yeah, this is the answer that we are getting. Okay. Next, del cross FR R vector. Next is del cross FR, del cross FR R vector. So what will happen? Sir, FR will come outside as it is, and this del will say that I will deal with R vector. Then del will say that I want to deal with FR, then cross product with R vector. Understandable? So what result this will give you? 0. This will give you the result of 0. So 0 plus del FR. What will be del FR? That will be F dash R R cap cross product with R vector. Now R cap cross product with R vector, R cap cross product with R vector is nothing but 0 only. So 0 multiplied with anything will be 0. That's the answer of del cross FR R vector. Okay, that's the answer. Next question. This is a gate QIQ only. Del dot R square del ln R. Del dot R square del ln R. What do you think? What you will do? Sir, blindly R square comes outside. This is what you will try to do. Look, one thing, this you can solve, no? Right? You can solve it. What it will become? 1 by R del dot. It is not dot actually. Here it will not be dot, right? Or it will be dot. Because del ln R will give you a, yeah, it will be dot only. Yeah, this will be dot only. R square as it is. Now what will be the result of del ln R? That would be nothing but 1 by R cap. This is multiplication. This is simply multiplication, nothing else. So result of ln R would be, this is nothing but gradient of ln R. What is gradient of ln R? 1 by R cap, differentiation of this. Then simply take the direction of R cap. What you are getting? This R and this R square get cancelled out. So you are getting del dot R cap. This is R cap. Now what is R cap? What is R cap? R vector is nothing but a magnitude of R with the direction R cap. So what you are getting? Del dot R vector. Now what is the answer of del dot R vector? That is nothing but 3. So 3 is the answer of this question. This is a gate examination problem only, but this is how you will be solving it. So that, sir, del ln R, gradient of ln R will be 1 by R cap. Now 1 by R cap, so R cap I am getting, which is nothing but R vector. So del dot R vector will be nothing but 3. That's the answer, job done. Okay. So here we end our lecture of differential calculus. Vector differential calculus we have completed. In the next lecture, we will study about vector integral calculus. Vector integral calculus we will study. So here our differential calculus is completed. Thank you very much. Let's meet in the next lecture.